So this video walks you through solving a system of equations by graphing. You can either use y equals mx plus b, you could use intercepts, finding the y-intercept or the x-intercept, or you could use a table of values, or really any method that you want to get those equations onto a coordinate grid. I'm going to use slope-intercept method, but if you want some more information on how to graph, check out some of the other videos on how to graph individual lines. When you get the lines onto your grid, a couple of things might happen. One thing that might happen is that the two lines that you graph might be parallel to each other. And if that were the case, I know those lines don't look terribly parallel, do they? Try this. There we go. That's a little bit better. If those two lines are parallel, that means that they are never going to cross each other. There will be no intersection. And when this happens, we say that there is no solution, because the solution to a system of equations are all the points that make the equations work, or all the points that the two graphs share. So basically what you're looking for is a place or a point where the two lines are crossing each other. If they don't cross, like two parallel lines, then you say there's no solution. Another thing that might happen is you might have one line, graph one line, and then you graph the second line, and it turns out that that second line is really the first line, the line that you already graphed. You end up with the same line. And if that's the case, you've graphed the same line two times, we say that there are infinite solutions. And this is because those two lines are intersecting everywhere. They have all those lines in common. The third thing that could happen is that you might graph a line and then graph a second line, and they do indeed cross each other at exactly one point. And that one point is the one solution to that system of equations. We're going to end up with one solution in the system that we're going to graph today. If you'd like to see an example of no solutions or infinite solutions, make sure you ask in class tomorrow, and I will either make another video or show you right there on the spot. So I'm going to use slope-intercept to graph my equations. So that means I need to get both my equations into this form, y equals mx plus b, with y all by itself on one side. And then I will use the intercept to graph my first point and the slope second to figure out what the rise and the run are, and graph the rest of the points. So let's see, that first equation is good to go. Y equals -5 minus x. That is all by itself, or y is all by itself. But the second equation, x plus 3y equals -15, is going to take some work. So let's do something with that. X plus 3y equals -15. I want to solve this for y. I want to get y by itself. So the first step I'll take is to subtract x on both sides. That leaves me with 3y on the left, -15 minus x on the right. Then I'll divide through each term by 3. And now I have just y on the left. -15 divided by 3 is -5. And the last term, -x divided by 3, this is what I'm going to do with that. So there's really that invisible 1 in front of the x, so I could write this as -1x in the numerator divided by 3. And then I'm going to separate out the fraction -1/3 from the x and rewrite it as the coefficient -1/3 times x, and write that at the end of the equation, -1/3 x. All right, now I've got an equation that I can graph. Y equals -5 minus 1/3 x. The first equation, my y-intercept is 0, -5, and my slope is -1/1. The second equation, my y-intercept is also 0, -5. Well, I wonder where these two lines are going to cross. Big surprise, right? My slope is -1/3. But we'll go ahead and graph both of them anyways, just so you can see how that looks. All right, so my first equation is here. My second equation is here. Let's put them on a set of axes. Here's a y-axis and an x-axis. So my first equation, y equals -5 minus x. Start at -5. 1, 2, 3, 4, 5 on the y-axis. And then go down 1 to the right 1, down 1 to the right 1, down 1 to the right 1. And I'll also make some points going in the other direction just so I can get a nice line. Wow, that wasn't so great. There we go. It's a little bit better. And I'm going to label that line with the original equation, y equals -5 minus x. Y equals -5 minus x. I'll use a different color to graph the second equation, just so it's easier to see what's happening. So I am starting at 0, -5 again, -5 right on the y-axis. And now my slope is -1/3, so I'm going to go down 1 over 1, 2, 3 this time. Down 1, 1, 2, 3, down 1, 1, 2, 3, and for good measure I'll go in the other direction a couple of times. Oops, that was just 2, 3, and then connect those points with a line, and I'm going to label that line with the original equation. So the original equation, where the heck is it? X plus 3y equals -15. X plus 3y equals -15. And now I am looking to see where these two lines cross each other. They cross each other at exactly one point. That one point is my solution. And the solution to the systems of equation is 0, -5.